So I'm going to teach you the easiest way to solve the validate a binary search tree problem. So that method is called the limit method. The limit method. Okay, so what does the limit method say? The limit method states that for each node, check if the value of the node falls within certain limit, and if not, return false. So it means, for instance, for the root node, we should have a limit, and the base limit is going to minus infinity to plus infinity, and we're going to check if the root node is falling between these two, and if so, no problem. But if it falls outside this limit, then we're going to return false. So let's say we have this on the root. If we move this way now, the values on the right or on the left here have to be less than the value 9. It means that the upper limit going now to the left, the upper limit would adjust to the value of the current node. So in this case, let's say we have this to be low and we have this to be high. So once we move here, the low remains the same. So it's going to be minus infinity, but now the high is going to change to the value of this place, which is 9. Okay, so when we are here now, we're going to check if 7 falls between these two. You can see that 7 falls between minus infinity and 9, right? So 7 is less than 9 and is greater than minus infinity. So this is fine. But when we now move this way, we are going to now adjust our low. We are going to adjust our high to 7 and the low remains minus infinity. And the high now is going to adjust to 7 because whatever is here should be not greater than 7. Okay, how about moving from here to here? In this case, our low will now have to adjust because whatever is in this place should be greater than what is here. So this should be the lower limit at this point. So our low should be 7 and our high should be 9, which is here, right? Sorry, which is 9. So I have to check if 6 is between 7 and 9, and it's not. It means now that this tree is not valid. So this is the limit method, how it works. Let's see how it plays out in code, and we are going to appreciate exactly what is happening here. So first I'm going to kind of increase my fonts a little bit. So the first thing we want to do here is to write a helper function that takes a node and takes two limits and simply checks if that node's value falls between the two limits. So I'm going to call this function valid. I'm going to say valid and specify a node and specify low and high. And then we are going to check first if the node is none. So if not node, we are going to simply return true. The reason we are going to return true when it's an empty node is because an empty tree or an empty node is a valid node as well. So I'm going to check if the node value falls below the lower limit. So if node.value.val is less than or equal to, because in binary search tree equality is not allowed. This has to be strictly less or high, less or greater. So if node value falls below the lower limit or is even equal to the lower limit, we're going to return false. Okay, so actually this is true. And this will be false. Okay, so again, we are going to check if the node value falls above the upper limit. So I'm going to say nodes.val is greater than or equal to high. At this time, we also return false. Okay. Now we have checked these two. Now we're going to call the same valid for the left and right children of this node. So we're going to say valid recursively now because we are going to call it recursively. So I'm going to specify node.left. And remember when we are going to the left, now the lower limit remains the same and the upper limit is now going to change to node.val. We are going to do the same thing for the right subtree. I'm going to say node.right and the lower limit is now going to change to node.val and the upper limit is going to remain the same. And this is going to be AND because we are going to make sure that both of them are true for us to return true. So I'm going to return, so let's make sure. sure I have this. Okay, so let me take out this. Why do we have this error? Okay, so we are going to recursively return valid return for the node.left. Okay, we're going to call it for the left and call it for the right as well. Okay, so why do we have this error here? Okay, so I'm going to say if, give me 1 second, let me just correct this. Okay, so I have to put it here. Okay, so I'm calling this function recursively, and I'm going to actually return here. So when both of them are valid, we are going to return true. And we are now going to call this function a valid function on the root. So I'm going to say return valid. Now I'm calling it on the root. So I'm going to call it on the root, and I'm going to give it the base case, which is minus infinity and plus infinity. So minus infinity is going to be floats, minus inf, and plus infinity is going to be floats inf. Okay, so this is fine. Great. So yeah, so this is in the same line. Okay, so this should be fine. So let's run it and let's see what we have. So I'm going to run this code now and let's see. It says node is not defined. Let's see. Okay, so this actually should be in here. Okay, so sometimes I don't know. So yeah, so let's run it and see. Float is not defined. Sorry about this. This is going to be float. Okay. Yeah, so I think it should work now. Let's see. So it's accepted, and let's go ahead to submit this code and let's see what we have. So I'm submitting now and speeding up. Okay, so let's just check here. And it says success, it works. So you can see that my code runs faster than 97.87 on Python 3 online submissions. So I'd like to thank you for viewing. Please remember to subscribe to my channel. I remain Kind on the Tech Pro, and I'm always there for you.